units, and then it's going to go up 8 units in the y direction. Okay. Let's do part B. Part B says 4u minus 5b this time equals what? So we got 4u. 4u was negative 10, comma 8 minus, and then 5b. Where's 5b? We already made it. It's going to be negative 30 and then 20. I don't know if you can see that or not. I'm going to move it over just a little bit so that you guys can see it. Again, that's 4u minus 5b. We add the extraction this time. There's a minus, we have to distribute the minus. So negative 10 plus 30 is going to be 20. 8 minus 20 is going to be negative 18. Negative 12, excuse me. That's your answer. Or it's going to be 20i minus 12j. That's also going to be the answer in ij notation. I got a different answer. Oh, what am I doing here? Did I do this right? Oh, that's 20. I have to use 20 here. My bad. I should have used this notation. 20 comma negative 12. My answer is going to be different because I looked at the answer in the book. Quite a bit different. So 20 minus negative 30 is going to be 50. And then negative 12 minus 20 is going to be negative 8. Wait a second. Negative 12 minus 20, negative 32. Sorry about that. Sorry about this. I should have used this one. I didn't distribute all the way out. Okay. Or it's going to be 50i minus 32j. ij notation. 50i minus 32j. Very good. Part C. Let me do this right here. Find the magnitude of 4u. Is it 4u? Yes, 4u plus 5b. That's part C. We used the answer that were given in part A, right over here. That's going to be our A value. That's going to be our B value. So you have to figure out what this is first before you can actually take the magnitude. So the magnitude of that is the square root of a squared plus b squared using the Pythagorean theorem. It's going to be the square root of negative 10 squared is 100 plus 64, which is going to be square root of 164. That's your exact answer. I believe you can probably simplify that if you want. Reduce the radical probably by 4 at least. 41. Yeah, it's going to be 2 radical 41, and if you do that on a calculator, it should come out approximately 12.8. Okay. We're going to be doing the dot product next. So how do we do the dot product? What is a dot product? That's a really novel concept, new concept. It's just it's going to be a little bit difficult to do. Here's the definition of the dot product. If you have a vector u of a comma b, and vector b is c comma d, the dot product u, big dot v is equal to, we're just going to multiply the x coordinates a times c, when we're going to multiply, plus b times d, and it comes out to be a scalar. That's the definition of the dot product. So we multiply these x coordinates plus multiply the y coordinates. Let's do an example of that. The example 6 that they gave you in the book. the vector u looks like this: 3, 4. It's a pretty easy concept. V is equal to 2, 5. I want the dot product. U dot V. It's kind of like multiplying, except you're actually adding the x and the y coordinates. So U dot V is equal to 3 times 2 plus 4 times 5. It's the product of the x's plus the product of the y's. You can actually extend this to 3 dimensions if you want. Just product of the x's plus the product of the y's plus the product of the z's. That's 6 plus 20 should be 26. Is that our answer? Let me check the book. 26, yes. The second question is part B. They give you negative, I'm going to write it this way, negative I plus 2j, and the dot product of that. Times 3i minus 5j, and change into interval notation, change into short notation, negative 1 comma 2 dot 3 comma negative 5. We multiply that out. The x coordinates, negative 1 times 3 plus 2 times negative 5, which is equal to negative 3 minus 10. It should be negative 13. And that should be pretty simple. Okay. Negative 13. I'm not going to do the third part. So when do we use the dot product? Well, obviously we did these examples for the dot product to use it somewhere. And there's a theorem using the law of cosines. U dot V is equal to the magnitude of U times the magnitude of V times the cosine of the angle between. It's the law of cosines. It's not that difficult to prove, and you're just going to use the law of cosines. So that's the dot product. That's where it's used. So this is in the case of the SAS situation. You have a vector u, a vector v, and you can try to figure out what that is right there. Okay. So example 7 says the vector u is 2, 3. Vector v is negative 3, 2. And I want you to find the angle in between those two vectors. Before I do this though, I'm going to try to draw it out. 2, 3, negative 3, 2. So it's going to be the first and second quadrant. 1, 2, 1, 2, 3. So that's 2 in the x direction, that's 3 in the y direction. And then negative 3, and then up 2. And that's vector v. And that's vector u. So you're going to use this formula, u dot v. U dot v is going to be negative 2 times negative 3 is negative 6. Plus 3 times 2 is 6. Equals, on the right side, the magnitude of that, 4 plus 9, square root of 13, times the square root of 13, times the cosine of the angle theta. You notice that on the right side, left side of the equation, you end up with 0. Equals 13 times the cosine of the angle divided by 13. Cosine of the angle is equal to 0 over 13. It's going to be 0. What angle will give you 0? You can figure it out using the unit circle, or you can use your calculator. It should be 90 degrees. So I had that memorized. It's quite significant. this problem right over here because of the fact that this is going to be 90 degrees. One of the byproduct of this theorem right over here, I don't even know if there's name of a theorem. It's the dot product theorem. I don't know. Anyways, so when you use the dot product theorem and the dot product for u times v, if it equals 0, you're going to have a 90-degree angle. Always you're going to have 90-degree angle, and it seems to be that if you take the slope here, multiply by the slope here, you'll always get -1 as well. So theorem 7.2, if v dot u or u dot v is equal to 0, then u and v are perpendicular. And there it is. Example number 8, last page. We'll try to figure this out. Okay. Part 1, here's a vector u equals 8i plus 6j. Vector v is equal to 3i minus 4j. And vector w is equal to 4i plus 3j. And we want to see which ones are perpendicular. Let's go u dot v first. Vector u is 8, 6 times the vector v, which is 3, -4. That becomes 8 times 3 is positive 24, plus 6 times -4 is -24, and yet end up with 0. Therefore, u dot v, u is perpendicular to v. Okay. Let's go u dot w. It's 8, 6 dot 4, 3. So that's the ij notation. That's the simple notation. 8 times 4, 32. Plus 6 times 3, 18. Does not equal 0. Therefore, u is not perpendicular to w. Let's see the third part, v dot w. Perpendicular, question mark, right? That's what we're trying to find. See if they're perpendicular. Vector v is 3, -4 dot w, which is 4, 3. That becomes 3 times 4 is 12, plus -4 times 3 is -12. That does equal 0. Therefore, v is perpendicular to w. You don't have to necessarily draw these out on the xy coordinate. You can kind of figure out mathematically. If you want to draw it out in the xy coordinate, verify that they should look perpendicular between these two, v and w, and u and v. U and w does not look perpendicular. Okay? Let me see if I want to go over anything else. I think that's it. Thanks, guys.